So, Bigpod,
What?
we have moved social media platforms.
Yeah, I know.
Yeah. So I set you on a task to spin up Mastodon, and you did it in like record time. You're just like, yeah, I got this. Like, oh, well, okay. So see you in like a week. Took less than a day, and I can report that I had an hour's worth of issues and only really made one complaint, and then you got that fixed pretty quick, probably because some silly DNS thing with Federation, because Federation wasn't working, and we're on our own Mastodon instance, which means that I get to talk with all the friends that the previous Mastodon server that I was using was blocking without actually notifying me that they were blocking them, because I didn't know that they were blocked.
More on this after this cue of music.
Hey guys, welcome to No Tux Allowed, a Tuxbase Media Group production. I am your host, Josh, and today I am wearing the beautiful white t-shirt. This is not the brand new one. This is one that I already had that was actually in relatively good shape, so I kept it. But I have brought today my friend all the way from the European country of Slovenia, Mr. Bigpod. How's it going today?
Doing good.
Well, that's good to hear. I hear that your shirt is wonderful today.
Yes. Mount Everest.
That's right. Okay, so we were talking a little bit about Mastodon earlier today.
Yeah.
Can we get like a general overview of generally how we got Mastodon up and working? Because I'm kind of curious on this as well.
I copied a Docker file, a Docker Compose file. I copied some bits and pieces of Nginx. I did a Docker Compose up -d, and it started working. It's a bit more complicated than that in reality, but that's the gist of it. So it first off starts with the Docker Compose file and a .env.production file where all the environment variables are stored. I edited those two files to fit my system, specifically, and to fit my requirements for potential scale, because there are some internal talks how we're gonna use this instance. More on that later, possibly months later.
Yeah.
So at this point, I had Docker Compose file and a .env file. So in the .env file, things that I cared about were, of course, secrets. And one other thing that I cared about was the information for this thing called S3. S3 being this thing that you can use to store files in object storage. So we're using this already with our podcast platform called Castapod, and it stores our media files like video or audio.
Yeah.
In
yeah.
this case, it stores all the images and stuff like that you'll be accessing frequently, but are large enough to not smart to actually keep on actual disk of the server.
Right. Because it just makes no sense, because Mastodon is a Federation enabled social media service.
Yeah.
And so while this service is up and running, it's going to be talking with basically all the other servers on the Fediverse to build up like this massive global timeline, which is probably like one of my favorite parts of it, where I just see that without having to be on like this massive platform. But the cost of that is that it's going to grab like at least low quality renders of images and videos and stuff like that, and it just doesn't make sense for you to store that on our little VPS server, because heaven forbid, eventually that disk will get full.
Exactly. So another thing that I really cared about, this is mainly for me to have peace of mind again if I'm trying to scale in the future, was to have Redis be prepared for scale. So, or in this case, we're using Valkey. So you have multiple ways to configure Redis or Redis capable uh, database. I mean, in-memory store database. So it is actually capable of RESP, Redis Endpoint Service Protocol, I think, something like that. Uh, and in our case, again, we're using Valkey. So to get what I needed, there are ways to in Mastodon to define for Redis to have multiple databases or one database. In our case, we're using three because for one, the Redis is extremely well optimized. Basically, if you're not putting anything in it, it uses barely any resources. So I could actually put that little bit of resources it actually does use and multiply it by 3 because we're already having one Redis instance, so added two more into the into the network. Specifically, I split off caching, so that's small scale caching of texts and similar things, and the queue system. So one of the more better optimized things about Mastodon that I like, despite the fact that it's using Ruby as a language. Oh god, Ruby. It uses this thing called Sidekick, which allows you to process asynchronously tasks which are added into this set of queues. It has 6 queues, and these are stored normal in Redis. In
Right.
this case, we have a separate database just for those 6 queues, which may seem strange, but it is basically great because if and or more likely when we decide we can scale, uh, patreon.com no tax allowed would help. Uh, every dollar would help us with that
Oh
goal.
yeah. And when we're talking about scaling, we're not necessarily talking about, like we're talking about basically just opening this up for like public registrations.
Yes.
For like you, the listener, just going to our service and just starting up an account.
Yeah.
The
So
the big the big thing that we noticed with Sidekick in particular,
yeah.
because this is something that we learned when I went to move to the server,
Yeah.
because I have. So I moved from Mastodon, right? Previously, which is my previous Mastodon instance. On that instance, I had like 350 or so registered followers. So I went to move to this server, and I just used Mastodon's built-in import tool to just transfer my file over the Fediverse from Mastodon server to our server, which is also a really cool thing that you can just do with Mastodon. Thank
Yes.
you for that capability. That said, obviously, I quite a few of the people that follow me just don't seem to exist anymore, and that kind of just caused some issues with the psychic queue. But it does get a little intensive there for like for the infrastructure. So
Yeah.
we did have to step up that VPS just for a little bit. Go change it from like a 2 core system to a 4 core system. Just so we can have an up and running server.
Yeah, but at that point, I also did multiple replicas of Sidekick, so I could actually run just as much as possible. But in
Yep.
long term, if I was actually going to run this, I would actually split each queue into its separate Sidekick runner.
Right. So basically, just like have a dedicated psychic machine.
Yeah, which has like for in each queue of a 6 would have its own process. Right now,
Yep.
all of them running in the same process, which they can split up in 5 threads. It's actually a complicated thing to do, but yeah, like, it's that's the only thing I like about Ruby. It's Sidekick. Well, and now since I have everything like nicely split up, at any point, since I have all Redis databases split up at any point, all we have to do is if we want to open up, all I have to do is just pro- properly, at best, if you're gonna have a lot of RAM usage, just chuck one or the other of the Redis databases on another node, and boom.
Right.
That's the great thing about preparing beforehand, which is
Oh
what
yeah.
I did. So I was thinking about possibilities of the future, and because of what I already told before, we aren't really compromising on anything if we do not open up. We do not lose barely anything.
Yeah, that's true. Lighted. Uh, th- we also have another service running on this one wonderful server that we're running as well. We have a full Nextcloud instance running as well,
Yes, yes,
which we haven't ran into like performance limitations on that yet.
yeah, but that's mainly because it's already performing pretty badly
Yeah, yeah.
in
I mean,
general.
it's about as good as we expected it to be, which is
Yeah,
probably it's right in our goals. We're not really like pushing the huge things in Nextcloud that Nextcloud is technically capable of,
yeah, we're just
but
doing it for internal usage.
yeah, it's just internal usage, like just sharing our show notes and like the video file that I record that I can then offload to editor
Yeah,
and so on. So we got that because prior to then we were kind of just using like janky here I'm going to rsync my video file up to the web server and then you pull it
yeah,
down from like this random folder I was /serve.
something like that.
Yeah. It's a little bit nicer of a process. That said, we're probably not going to be installing like the Nextcloud client on our computers and connecting Nextcloud that way. Well, I'll just
Yeah,
use the web UI. It'll be fine.
something to that effect.
But overall, for like our second to bottom tier that's available from our VPS provider, it's working. I've got no complaints about it yet. And of course, we can always just shut all this down and go back to what we were doing too. If
Things don't
it
work.
just
Yeah,
turns out to be that bad.
yeah.
It's as easy as going to Fastodon and clicking cancel button. All right, so in the meantime, we got a little bit of news we can talk about, Bigpod,
Yeah.
because I got reading through the RSS feeds, and I hit like this rather confusing article title with Perplexity claiming that Amazon is doing things that are bad for the consumers because of Amazon, and that article made no sense. So I had to scrub this website manually, which is one of those news websites that likes to come up with lots of ads. I enabled the ad blocker, and so far, ever since I pulled this up, as soon as we started recording, I've blocked over 2,000 scripts on this. This website's
Oh,
kind of cancerous, so I
yeah.
apologize about the links. I apologize about the link, but realistically, this is like the article that explains what's going on. But anyways, Perplexity AI, the company, came out with their own web browser. It's one of these AI-enabled web browsers that has the full-blown AI integration into it. So you have the chat assistants. It'll actually do things for you, such as buying things from Amazon.
Oh yeah, the
Yeah,
Perplexity
yeah.
browser.
Yeah, the Perplexity browser. They have this bot built into that browser called Comet that'll just buy stuff. Well, Amazon doesn't like this.
Who could have
It
guessed?
Yeah. First of all, it's apparently a violation of the Amazon storefront's terms of use. So if you go to Amazon.com and buy things, you're subjected to the terms of use of the store page itself. And
Yeah.
apparently, automatically buying things off of Amazon without using like their built-in tools to do that is a big no-no. And they're also saying that it gives poor customer experience as well. So Amazon decided that they're going to hire the lawyers and throw them at Perplexity for this.
Interesting.
Yeah. Now, as we're recording this, this is a news story. This article, this happened yesterday. So we're still very early days into this. But I think that this is an article that we should probably keep an eye on. Even though this is a US lawsuit, it could be something that, we could see have ramifications all the way into the European Union.
Yeah.
Because this is how far are we willing, this is literally a question of how far are we willing to let AI assistants go? That's really it.
Yeah.
Because I'll be honest with you, I don't want to be forced to use a web browser that has this AI built into it and then have some kind of software bug go on where, I could just be randomly talking about, say, Gemini, which I am intentionally mispronouncing that because of last week, by the way. We could just be having casual confirmations. Next thing I know, my phone just lights up and goes like, hey, I bought this thing for you.
Yeah, that would be great.
I am sure that there's a venture capitalist out there somewhere that goes like, hey, that's actually a great idea. We should do that. No, don't do that.
Bad venture capitalist. Bad venture capitalist.
Yeah, bad venture capitalist. We don't want that. Now, we can just... It's fine to add it to the cart, but don't make the transaction, please. Let me do that manually. At least that's what I'm hoping comes out of this. And of course, since that's early days, that's really all we've got to talk about it. But we've also got a big one coming next about Android. Now, Bigpod, you remember hearing a couple years ago about Epic filing lawsuits against Apple and Google over the app stores?
Yeah.
Well, we finally got a settlement offer, and it was accepted.
Ooh.
And Google just told us what it's going to be doing today. So, the settlement was reached yesterday, and Google is announcing the changes for the Google Play Store today. Now, how it currently works is for, like, say, an app that you would buy off the Google Play Store, or really just like any purchase in general, Google will take a cut for it. The current rate being 15% up to the first $1 million, and then 30% afterwards. So it starts cheaper and it gets a little bit more expensive after you cross that $1 million threshold on purchases. And I think it's based off of like a time frame too. So if it's like a set amount of time, you would have to deal with that. But anyways, they're changing that cut that Google would take. Now it's going to be starting at 9% with a total cap of 20%. So about a third less there in total for these bigger apps. But it's also has to have the ability for the Google Play Store to index third-party application stores as well, and be able to present that catalog with first-class support.
Huh. So,
the Google Play Store with the Epic App Store,
Yeah.
Would you, when you go to install Fortnite, where do you want to install it from? Do you want to install it from Google Play or Epic? That's it's going to ask you that when you go to hit the install button.
But I have a question for you. Maybe you know the answer. What will this do to Google's idea of developer verification scheme? Do you know? Because, well, if you have to you have to actually take third-party stores, that could be a problem for their developer verification scheme, because anyone could upload onto any store without being verified, and they shouldn't be able to be mad.
Well, you see, Google is allowed, under terms of the settlement, to be able to create, in quotes here, quotes, reasonable requirements, end quotes, for certifying these app stores and the applications that they distribute. So, that Google verified app thing that we were talking about a couple weeks ago, That can still be
Yeah.
a thing, as as long as that app developer is registered with Google. Because you got to remember,
Hmm.
that's not just for like apps that are being installed from the Play Store, but like any application being installed
Yeah.
on Android itself.
Yeah.
So that's so by that very vague definition, that should still be appropriate.
Hmm.
That
Interesting.
said, to register your app with Google, it's free to do anyway. So it's not like there's any financial cost. It's really just a question of privacy.
Yeah.
That's really what it is. But I'll be honest with you, if I'm installing an application on like my system and I think that it's a critical application in like my workflow, then I think it's kind of nice to have like that verification step. Like if say this was not Google, but say like the Mozilla Foundation or like the Debian project that's like doing this instead, that's responsible for authoritating this instead, would this really be a conversation that we'd be having?
No.
Right, right. So I think that ultimately I'm kind of coming around to the idea that yes, this is probably going to be a thing, and it's going to be a thing that we're going to have to live with.
Yeah. I know
uh,
that
that
much.
that's really how it is. Lighted, Bigpod, you and I are Linux users, and heaven forbid if we're installing anything through our package managers. A lot of package managers have GPG or have at least a 256 checksum verification.
Yeah. Yeah.
So yeah, that's just what we already have to deal with. It's just that Google's not the one that's authoritating it currently.
Exactly.
Right. So the next one here is an episode that I pulled from Tom's. Is an article that I pulled from Tom's Hardware, talking about the Morris worm. Now, Big Pod, the Morris worm has not been a thing since like the 1980s. So this is more of just one of those historical articles that I get in the RSS feeds every now and then that just like pique my interest, and it piqued yours as well too, because as soon as I mentioned it to you, you were firing off Google like a savage, looking to see how this thing works.
Something like that.
Yep. But anyways, this week as we record, in the wonderful year of 1988, John Tappan Morris unleashed an Eponymous worm upon the internet. The wave of infections grew to about 20, or grew up to roughly about 10% of the entire internet within 24 hours. You gotta remember, this was 1988. The internet was much smaller back then.
Yeah.
But this is also like very early days in the internet history as well. So this is one of the very first big like virus fiascos and malware infestations that we had to deal with, and it was taken appropriately, I think.
Yeah.
So I know that you did a whole lot more digging into what the Morris worm itself actually did than I did. I just got like a top level kind of deal on it. So Big Pod, what is the Morris worm? What did it do? And how did we get around it?
So Morris worm, as Josh said, was created by Robert Tappan Morris, who was at the time, I believe, a student on Cornell University. To hide his identity at least a bit, he launched the worm from MIT's network. It was created mostly by Morris with some help from others, I believe. And he even talked about it with some friends. At the time, Worm exploited multiple vulnerabilities of targeted systems. Specifically, those systems were BSD Unix, or Berkeley Unix, to be correct, what later became known as BSD, Berkeley System Distribution. the mother of what became FreeBSD and many others,
All the other
including
BSD based operating
yes,
systems.
including things like Nextstep and Darwin, which together became the very basis of macOS. So the three vulnerabilities it exploited were, or the three most important ones were a hole in the debug mode of the Unix sendmail program. That's why BSD was, or Berkeley Unix was so attacked, because it used one of its well base programs really. It also did a buffer overflow or overrun hole in the finger network service. I don't know what the finger network service is, so let's learn. It's a old protocol for some status report on particular computer system or particular person at network sites. Interesting. You probably should look into what this is. But let's go back to Morris worm. And lastly, uh, the it abused the transitive trust enabled by people setting up network logins with no passwords requirement for remote execution with remote shell and stuff like that. Well, logically, at the time there was very little look on security throughout the networks, because who's gonna hack us was the
Right?
idea,
It's
really.
1988. Who has a computer that they're willing to do this kind of stuff from?
Yeah,
You know,
and who's
that
gonna attack them? Like, yeah, like, and even the things that they were scared of were many times the things that were actually like more pranks on each other within the same room or possibly on same machine. So on top of that, Worm exploited weak passwords, such as words used by spelling checker and password using simple patterns.
yep, that's nothing new.
And quite quickly, Morris's exploits became actually obsolete due to the commissioning of RSH, the remote shell, and
Yep.
thanks to fixes to SendMail and Finger, and widespread network filtering and improved awareness of weak passwords. Yay!
Yay! Passwords for everything, and preferably slightly longer and slightly more complicated kind of passwords too. While we're at it.
Uh, Morris did say that he did not intend for Worm to be actively destructive, instead merely seeking to highlight the weaknesses present in many systems and networks at a time. The consequence
So,
of
not black hat, gray hat.
yes, the consequence of what he actually wrote, whether it was actually far more destructive than he imagined, and far more spreadable than what he originally planned. It was initially programmed to check each computer to determine if infection was already present, but Morris did believe that there would be some security in place, and he programmed Worm to copy itself 14% of the time, regardless of the status of the infection. Because one of the things that it did have was checker whether it was actually on the system.
Yeah,
This
because
is
heaven forbid, we're doing good sysadmin things here. We have the program check to see if it's already there.
yes,
If not, it'll just move on to something else.
yes, but because it did do that for every 14%, it did actually just reinstall itself. This resulted in the potential of being infected multiple times, and due to, well, it's 1988. Remember, those are not really our 16 core machines.
No, it was single core, single thread. This is one busy thread.
Yes, 100 megahertz or even less. Uh, and each infection essentially slowed down the system down to unusability, or even crashing it completely. Essentially, it had the same effect as a fork bomb, and it crashed multiple computers multiple times. Actually, as I said before, it only really affected the systems running 4BSD, Sun 3, and similar Unix-based systems, uh, and it really only affected DAC VAX machines.
Yeah, the main reason why this was able to propagate so easily across the world is that the www standard was not a thing yet. They were still using the old NSF net, which is the ARPANET successor.
Yeah.
So they were using phone lines, yes. They just weren't using like TCP, IP, or anything like that. They were just using a whole different thing that was basically built for functionality,
Yeah.
not necessarily with like any security considerations, because this was still the early days. They wanted it to work, and a lot of times it would just transfer over like the FTP servers or even telnet connections.
Or things it was programmed to look any
Yep.
kind of connection. Like there were different types of connection that were existing at the time, because remember we are talking about a time when there were connected into this network 60,000 computers,
Yep.
not much more. Universities and government, that's who had those machines, and the the actual like cost goes anywhere between $100,000 to $10 million,
Yeah.
because the problematic part with the machines being, well, the machines of the time, the removal of this worm many times took multiple days,
Yeah.
and
And
systems were essentially useless until disinfected.
yeah, and you got to remember, each system. This was back in the time of terminals, like
Yeah,
physical terminals. So
yeah.
one system could have been like maybe 6 to 8 user systems. So this did impact a lot of people.
Yeah,
Lighted, it was 10% of the internet.
yeah.
If that happened today,
Probably 10% of the internet, something like that. Yeah.
yeah, if we were to see that happen today, it'd be basically just like that AWS outage we were talking about just last week, all over again.
I remember a couple of years ago, 10 years ago, there were some viruses that did actually affect machines on that scale, and even then, nobody batted an eye
Yeah,
because of how widespread this kind of stuff can get. But on the other hand, how many machines there exist. Uh, a 10% can feel like a drop in the bucket.
it really can these days, and a lot of that we just simply think because that it because of how the TCP/IP protocol works. It's just like, hey,
Yeah.
if this machine's too busy or too awkward, we'll just go somewhere else. Heaven forbid, the connection might be just slightly slower, but it will still work. It's built with that redundancy in mind. NSF net was not.
Yeah, and basically, and to some, they point out that this is a very shows the very big danger of monoculture. Remember,
Yep.
running just one operating system, running just one set of libraries, running just having just one big network,
Yeah, because
because
there was no Windows or a concept of Linux distributions that did
yeah,
various different things back then. It was all Unix and POSIX compliant.
all that there were multiple
There were
Unixes,
multiple Unixes, yes,
and there
but a
were
lot
other
of
operating systems. Let's be
yeah,
clear, there were other operating systems, but and in this case, it is approximated at about 10% of the actual like environment. With his case, this would be NSFnet, ARPANET, depending on who calls it what. There were maybe 5,000 computers that followed all the checks, that had Berkeley Unix on it, one sort
yeah,
of Berkeley Unix. Guess what? That the problem if everything ran Berkeley Unix, or everything ran one of the Unixes that actually was affected by this, the whole of NSFnet would go down. That would have been a problematic. That's why it's so important that we run BSDs, that we run all sorts of Linuxes, that we run yes, Windows and macOS as well, because
Yeah.
in any case, even if there is a vulnerability that would affect every Linux system, there still exists BSDs, there still exist Windowses and macOSs. We cannot have just one operating system to be dominant. We just can't.
Yeah. That said, if you haven't tried out BSD on a system, FreeBSD does have its advantages, and there are a couple nice things that it does in comparison to Linux systems. Like I still find networking a pain on Linux systems sometimes, but of course I could also just talk about the fact that ZFS is native on BSD unlike Linux.
Yeah.
We have to use like crummy DKMS modules here in the world of Linux, but it's just there on FreeBSD. But
Yeah.
of course, if you're a FreeBSD user, I would like to chat with you guys with you one of these days, because like, how do you actually use your computer? Because I attempt to install FreeBSD every now and then, and I can get it working, but there's a couple too many gotchas I haven't quite been able to wrap my head around with on the FreeBSD system. Just a couple.
Yeah.
That might be my fault for trying to use FreeBSD on the current branch rather than the stable branch, but that's just because I'm that kind of a savage. But hey, I know if you're a BSD user, you definitely know how to send us an email. contact@tuxbase.com. Heaven forbid, you're probably subscribed to like 30 plus mailing lists, and you're dealing with that inbox every single day. We just know you are.
Yeah.
Or maybe you're smart and you make use of multiple email addresses because you just do that. Of course, if you're a viewer and you have comments on this episode, you can also just send us an email as well. Or if just go to YouTube and drop us a comment there, hit the like button a couple bit there, because make that algorithm work a little bit better. But of course, if you'd like to talk with each other in the general community, go to tuxbase.com/discord. We have lots of people in there. It's not like a massive 2,000 user system, but there are people in there and they do talk to each other. Sometimes we even talk in there. I was actually talking with HipDad in a voice channel the other day, Bigpod.
Really?
Yep. We're gonna get some pizza in a couple weeks. If you would like to support the show, because you heard us talking about setting up and spinning Mastodon, that's not the only thing we self-host in our lives, and it's not the only thing we ever want to self-host. Go to patreon.com/notuxallowed. Give us money so we can scale further, make ourselves nicer, and
that would be great.
Maybe one of these days a render server.
Ooh, that would be great for me.
It would be fantastic. Of course. We also need enough funding that way we could just buy the massive GPU server and just run our own AI stuff for the fun of it.
Yeah.
Have AI that we don't need to wait 90 seconds for a response for.
Yeah. Then I can do some of my own AI projects, which I do not want to do with public AI services.
Yeah. Of course, we need to update these Fediverse links right here. Unless they're already fixed. I don't know if they're fixed, but they should be showing up on the screen, because we are at mastodon.tuxbase.com now rather than fastodon.org or mastodonv2.bigpod.c. No, we need to fix that. We have our own YouTube channels as well. I'm at 10LeeJ and you're at Bigpod, if I remember right.
Yeah.
And of course, we will see you next week.
Goodbye.